Alright, so the next thing we're going to be talking about is equilibrium. Alright, so equilibrium is when the rate of the forward reaction, so rate of the forward reaction equals to the rate of the reverse reaction. Alright, and so this is specifically the rate. So something is actually happening. You know, you're converting the reactants into the products at the same rate that you're converting the products to reactants. This is different from just being at a stagnant state. Right? Reactions are constantly happening, but they're happening in equilibrium at the same rate. Right? So when we define equilibrium, we're always going to be dealing with this KEQ. Okay? So just to define it in an equation, it's going to be the concentration of the products over the concentration of the reactants. Okay? And so what this is actually saying is it's the equilibrium constant, and it is dependent on whether the reaction favors the reactants or the reaction favors the products. Okay? So it just tells you which side is more favorable. Okay? In the final equilibrium, will it be more products or will it be more reactants? Okay? And so for this equation above, we're going to have that it's c to the fourth times d to the fifth over h squared times b cubed. Okay? So it's dependent on the coefficients, but there's a certain restriction. Okay? So we don't include, so these are things that we do not include. And they're going to be liquids, they're going to be solids, they're going to be gases. We will use it only as the partial pressure. So the partial pressure will determine the concentration. And so these are things that we don't include, and this is kind of just an exception. So no liquids, no solids. If we have aqueous, great, we can use that. And if we have gas, we just use the concentration for partial pressure as the gas concentration. Alright, so after we have been given this equation, we've been given this KEQ, and we solved for it based on our equation. Alright, they'll also give us the actual concentrations of A, B, C, and D. Alright, so once we have plugged in these values for A, B, C, and D, we can solve for actual value of KEQ. Alright, so this KEQ value will be either greater than 1, equal to 1, or less than 1. Alright, so what do those each mean? Alright, so if KEQ is greater than 1, that means that the numerator is going to be bigger than the denominator, meaning favoring the products. Likewise, if KQ is less than 1, it's going to favor the reactants. Alright, if KQ equals 1, there is no preference, or none has a greater bias. You're not favoring either the products or the reactants. Alright? And remember, KQ is always in equilibrium. Okay, we use the concentrations at equilibrium versus Q, which is the reaction quotient, and you can think of it like real time. It's what's actually happened in real life. It's not when you're at equilibrium. It's just at any certain point in given time. Okay, so our Q is still going to be equal to this equation right here, but the only things that's going to change are the concentrations. The concentrations are going to change, which will affect Q. Okay, so Q is affected. It can either be bigger, it can be smaller. It all depends what your concentrations different in your current time versus at equilibrium. Alright, so likewise, when we had KQ, we determined whether it be less than 1, greater than 1, equal to 1. What does that do? We're going to have the same thing for the Q. Okay, so if Q is less than KQ, what is that going to mean? That means if Q is less than KQ, that means our reactant is going to be bigger. Meaning, in order to reach equilibrium, we're going to have to go into the forward direction and create more products and less reactants in order to make Q more equal to KQ. Right? Likewise, if Q is greater than KQ, that means our numerator is going to be bigger than our denominator, meaning we have too much products, meaning we have to go into the reverse direction. So it's going to favor the reverse direction. If Q equals KQ, well, that should be pretty simple. It means we're at equilibrium. So we're at equilibrium, so we don't have to do anything. Okay? It doesn't have to favor one side or the other in order to reach equilibrium because we already are there.